All right. Thanks, man. Hello, everybody. I've sent this message back to April 2010. You have just purchased a machine that's going to be racked in an actual data center that still exists in your time. And it's going to become the beginning of what you call Hudson Labs. I'm sending this from 2016, so welcome to the future. Let me tell you a little bit about it. In this timeline, you work for another company that has a name which your parents still don't understand. It's called CloudBees, which they still don't get. They work on enterprise Jenkins and continuous delivery things, which they also don't get. And those words might not mean anything to you now, but in the next year or so, this guy, Jez Humble, is going to convince everybody it's really important. In the future, everyone's got these kind of cool future-y names like Jez and Hightower and Nigel, I guess. You don't get a cool future-y name, though. You adopt this pretentious first initial that really just annoys the piss out of everybody. But we won't talk too much about that. In this future, all sorts of things are different. You've learned a lot. Things have changed. Macintoshes now look like a trash can or a watch. What else has changed? You would not believe who's running for president this year. But things aren't all bad, though. You work on an open source project now full-time. You're no longer just an angry developer who works on open source projects. You do that for your career, which is pretty cool. And that's the good news. The bad news is that you're ops now. I'll let you think about what that means for your life. Very soon now, though, you're going to get in this disagreement with this little bitty, they're sort of innocuous, this database company that's in San Carlos. You might not have heard of them yet, but you're going to have a disagreement with them, and you're going to need to build out independent infrastructure. You're no longer going to be able to rely on their resources, so you and the rest of the members of the project are going to have to build everything from scratch, starting in the middle of 2010. It's important that you choose the right tools. You're going to make a lot of mistakes, and I'm here to prevent that. But when you choose tools, think of tools that are going to make things easier for you, because there's so many things that are flying around right now that people are choosing them because they're the coolest, because this person says it's really nice, because this person says it's really nice. And if it's not going to make your life easier, don't bother with that tool. Only choose the tools that are going to make you go faster. And those are tools like Puppet and Jenkins. You'll learn more about Jenkins as time goes on. Whoop, I've got to change my notes that I've prepared to send this message. Anyways, only choose the good tools. But when you choose tools, keep in mind that you're going to have technical debt. There is no escaping technical debt. You're going to have problems. Nothing is perfect in your world or mine. But when you're choosing tools, think of ones that are going to make your life easier, the ones that are going to give you the information to migrate away or change the way that you're doing things in a way that's going to make your life easier. And generally speaking, every tool that you should be choosing is going to help you with automation. And that's the hammer for every single nail in your lifetime is automation. Automate everything that you can work on. And there's a couple different sectors where automation is going to be powerful and useful for you. And I'm here to tell you a couple of those so you don't make the same mistakes this time around in the cycle. Let's talk about security. You and everybody you know is screwing up security in 2010. And you're going to learn a lot in the process of provisioning infrastructure on how to make security better. And when you make these mistakes, it's really going to be painful. But first, let's talk about managing your secrets. Right now, the project is maybe 3, 4 people that really need access to secrets. And those secrets might be certificates or signing keys for the applications or API keys or API tokens to tie different services together. In 2010, there's not really any good tools for you to use to manage these secrets. In the next couple of years, R.I. Pinar, I think that's his name, very future-y. It's so future-y, it's just initials. He's going to create this tool called Hyra. And over time, there's going to be stuff built on top of Hira, like Hira GPG or Hira YAML, that's going to make your life easier. And the sooner you can get those secrets into Hira or something where you can manage them from one central spot, the better, the less technical debt that you're going to accrue. But really, Hira is just a means to the end. Really what you're concerned about is access control, and you are going to screw up access control at least 4 or 5 times between 2010 and now. And the services that you have to manage are GitHub organizations, LDAP, Artifactory, Jenkins itself, or even just basic SSH keys. And the way that you manage this access control is both going to be a source of technical debt, but also security problems for the infrastructure. In 2010, GitHub organizations are okay. They're not great. You can't do very much with them. And because of that, what you're going to end up doing is manually creating teams and manually creating write access, read access, and admin access to all of your GitHub repositories. Over the next 6 years, though, the project is going to grow from a few repositories with 10, 20 contributors to 1,200 plus repositories with 600 plus contributors. And if you continue to manage access control manually, you're going to screw it up. In fact, I know for a fact that you're going to screw it up because I watched you do it. The problem is GitHub's organization structure and the access control around it doesn't prevent developers who have write access from force pushing things. This changes eventually, but because you have such lax security standards right now and such manual access controls around your GitHub organization, there's going to come a time when somebody inadvertently force pushes the main Jenkins project repository, and it'll take you a week and about 4 people to figure out how to untangle it and get things back to normal. And it's not just GitHub organizations that are the problem for you. You're also going to manage LDAP. And with LDAP, it is a sort of clunky, difficult to manage tool, so you manage it manually for a long, long time. And I think it is until 2014 before you have any automation around LDAP, even just managing the schema, which means until 2014, nobody understands how LDAP works for the Jenkins project because you haven't automated it. On top of LDAP, you have services like Artifactory, which is where all of the artifacts like the jars, the wars, a lot of the packages that everybody's dependent on go. And like GitHub, there's this web-based UI for managing everything, which means you're not going to automate it. And as the project grows to that 600 plus contributors or 1,200 plus repositories, that means you're going to be either managing a lot of access grants manually, which sucks, or you're going to give everybody too much access, which is going to allow them to do things that they shouldn't be doing, either maliciously or out of incompetence. So it's very difficult to manage these types of tools, but I urge you now to start writing scripts, because the sooner you start writing scripts, the less time you're going to spend managing these web-based configuration tools like Artifactory, like GitHub organizations, or like Jenkins itself. Because you work on the Jenkins project now, it feels very natural for everybody to get access to configuring jobs, to adding tools, to changing things in Jenkins. But there's no audit log. You're going in and you're checking boxes. Because you aren't using the CLI scripting or the Groovy scripting that goes along with Jenkins, what ends up happening is when you have to rebuild clusters, and you will have to rebuild your clusters, you have to perform this kind of archaeology to figure out who's supposed to have access to what and where and why. So the sooner that finds its way into your source control, the less technical debt you're going to accrue around even just your Jenkins. You would think that the Jenkins project would be really, really good about managing Jenkins. But 6 years of experience have taught me that that's not quite the case. The other area where you really have to worry about your access control is your SSH keys. Puppet, that tool that you chose, comes with authorized key support out of the box, so you can manage authorized keys, which is really nice. But the problem is you don't manage private keys or role account keys or host keys between all of your different pieces of infrastructure. So access is granted to different roles and different sort of bespoke accounts across the infrastructure. And when one of those services or one of those role accounts gets compromised, or even you get a whiff of a compromise, you have to go manually hunt down where this particular account had access to. So the sooner you get all of your SSH keys, whether they're role accounts or personal public keys, into whether they're exported resources or an external node classifier, some external thing that has a central source of truth for all of your SSH-based access, you're going to have this festering technical debt sitting in the middle of your infrastructure. And the problem with having that disparate service or different access control is people will have access to your services, but they won't be able, or they will, excuse me, they will be able to access different things on the same hosts. You've now shipped this machine from ERAX to St. Louis, Missouri, where it's going to sit for the next 6 years, and it's going to run a myriad of services. And because it runs a myriad of services, that means when one is potentially compromised or one is weakened, it's easy to compromise the other after the fact. And there are tools in your time, in 2010, that help you solve this. There's virtual machines where you can spin up stuff on AWS, which is really great, but if you screw up the management of AWS, it costs you not just time, it is quite literally technical debt, and you will pay by the instance hour for all of your mistakes. So 2016 would like to ask you to use Kosuke's credit card. Don't use your own credit card. So when things go wrong, it's somebody else's money. In your time, you also have jails, which the only reason you're not using jails in 2010 is because you're too daft to know that they actually exist. In the future, you've also got containers, which are like jails and virtual machines or somewhere in between. And everybody's really hot to trot on containers in the future. And when Kosuke originally suggests containers, you're going to be a big pain in the ass about it because of all the hype. And while they don't solve every security and service isolation problem you might have, they are a huge step in the right direction, and even now they're getting better. And so not using them just because of the hype is idiotic, so I'm asking you not to do that. And all of this sort of wraps around to the security lifecycle of some of the different services that you maintain. And as time goes on, you've got to think about your infrastructure not as, I deployed an application, I'm done, right? Over time, these applications are going to change. They're going to have vulnerabilities. There's going to be things that need to be upgraded with them. And there's a couple ways that you can manage the security lifecycle with these applications. It takes you about 4 more years before you discover that there are advisory lists that you can subscribe to. The Ubuntu Security Advisory List you should be on right now in 2010. You should not wait until 2014 to get updates on security advisories within the Ubuntu project, which is what all of your infrastructure is based on. But once you have that information, knowing what applications or what services are insecure is not enough. You've got to have the automation to roll out security updates. And so having that information and being able to automate the security rollout is a huge step forward and prevents you waiting for years and years and years to roll out distribution or package upgrades. In about 2014 or 2015, everyone discovers that libSSL is a piece of shit, and you're going to have to roll out updates for that. And the more automation you have in place to manage the security lifecycle of these services, the easier you're going to have of a time to respond to all of these cutesy, special little OpenSSL vulnerabilities. But in general, the overarching theme that I want to impress on you in 2010 is that don't be dumb about security. You've got limited time, I understand that. You're going to make mistakes, I understand that. But think about security as a long-term thing. Don't think about it as a reactive incident sort of response type of initiative, because you'll just accrue more and more insecure services, more and more technical debt, because you either don't know about security advisories or you don't have the automation to react to those. And in general, security really sort of, like I said, everyone's going to screw it up, but put yourself in a position to where you can recover from screwing up. because it's not difficult to do a good job. And no one else is really going to notice where you haven't done a good job except you, the other infrastructure maintainers, and the NSA. But you'll learn about their thing later. And a lot of security and a lot of the technical debt that you accrue with security comes down to this manual work. And operations is filled with manual work. And some of it really just comes down to automating this is hard, which you are going to use an excuse. Kosuke is going to use this as an excuse. Every operations person you ever meet will use this as an excuse at some point. And they're all kind of full of it, yourself included. Because automating things that are difficult is part of what we're here to do in ops. And there's some things like difficult services like Jira or Confluence or Jenkins itself that are incredibly difficult to automate. But as you start automating different pieces of it, you'll find APIs, or you'll find scripting interfaces, or you'll find Puppet modules that somebody else wrote to make the automation of these things easier. With Jenkins, for example, you don't have to just spin it up and go check a bunch of boxes, for example. You can use this groovy scripting interface, or you can use the CLI, or even worst case scenario, and I really do stress worst case scenario, you can stand up a pristine Jenkins environment, make your manual changes, and then check configuration files into source control. All of that is still better than going into a production Jenkins instance and manually checking boxes, because that is immensely manual work, but it's also not repeatable. The other difficult services like Jira or Confluence, or any service that has a web-based UI and a database-backed configuration, those are going to be super difficult to automate. I don't think even in my future or my version of the future, people have figured that out. But do what you can. Try to script it in any way you can. There's also going to be a lot of custom packages. When were we going back to? April 2010. You're about 2 months away from making a very critical mistake of building, compiling, and installing software by hand in production that is so closely tied to the packages on the machines and the OS that is on the machines that you get prevented from upgrading distributions for about 6 years. So in 2016, you will have just decommissioned your first Ubuntu 10.04 machine because of these custom packages. And in the way distant future, you might be able to use containers to solve this sort of problem and just package things up into a container and ship that out into production. But even in 2010, you have tools like the Open Build Service from the OpenSUSE project, or FPM, which are going to allow you to build packages yourself that you can't get from a vendor and ship those out into production. And that's still better than manually building and installing in production like you're running Gentoo, and you're not. And then monitoring is another place where people say automating is hard. And even in 2016, people treat monitoring as if it's this dark art. And Puppet, for example, has had these Nagios resources since forever. I don't know why. I still don't fully understand that. But it's easy to automate Nagios. It's not easy to automate monitoring, because monitoring is not about setting up process checks or SSH checks or things like that. The hard part about monitoring that you're going to learn over time is that you have to know what working means for a specific service. A web application working is not HTTPD, the process is running on that host. It's HTTP is running, port 80 is open, port 443 is open. When I hit this URL, I get a 200 OK response back and a non-zero content length. And automating that is the difficult part with monitoring. And the sooner you start monitoring things and checking your monitoring in, whether it's Puppet or Datadog or anything, the better you're going to be. Because going back on an infrastructure that's been sitting around for 4 years and trying to retroactively graft monitoring onto it is tremendously painful. So each new service that you're going to roll out this year, I want you to think about how working state actually, what that actually means, because it's going to be really hard further down the line. And monitoring means you also have to think about incident response. In fact, even if you don't have any monitoring, you're still going to have incident response, because things are going to break. Nothing is going to work the way you expect it over time. And If you think about, would I rather have 1,000 emails from every user all at once telling me the service is broken, or have one PagerDuty tell me that the service is broken, you'll choose the latter every time. And that incident response is where you're going to accrue a tremendous amount of technical debt over time. And it really falls into two buckets, right? We've got our application problems, which some people might recognize as bugs. And every time there's an application problem, you're going to wake up, you're going to get an alert, you're going to log into a machine, and you're going to restart the application and go back to bed. And every time you do that, you're accruing technical debt. If you get an application issue alert at 4 a.m. and you don't collect diagnostics, or you don't write some automation around it, or you don't file a bug report, then it's never going to get fixed, and you're going to basically concede defeat that you are OK with being woken up every morning at 3 or 4 a.m. because of this stupid application issue. So if you don't react to incidents correctly, you're going to accrue more technical debt in the incident response than the actual incident caused. Another problem we have even now in 2016 is resource exhaustion with all these services in production. Somehow developers still believe that disk is infinite, and memory is infinite, and CPU is infinite. And you'll have all of these services that make these idiotic assumptions about what they can and can't do, and you're going to get paged for it. There's a few applications that treat cache as if it's this infinite thing that they can use, or with some applications, I won't name them specifically, you'll figure it out over time. With some applications, they won't actually run correctly without a populated cache, which might lead you to ask, how do you run those applications to populate the cache? That is a topic for a different discussion entirely. But caching is super difficult, and there's going to be some applications that, because they're just fundamentally broken, you cannot change how they react with cache, and you're going to get hit with incidences like this service is running too slow, or this service has a full cache and it can't run properly. And the worst thing that you can do is just flush caches for these things. And the worst thing that anybody else in the project can do is log on and flush these caches. And if you don't document what you're supposed to do when caches get exhausted, then people are going to take these little incidents and turn them into big outages as time goes on. There's also processes that leak file descriptors like nobody's business. The defaults in 2016 are still stupid for pretty much every service unless you change it. But when these services are running out of descriptors or unable to allocate sockets, if you aren't changing that in Puppet or changing that on the machine or filing a bug upstream, you're going to get continually woken up by these stupid, insufficient file descriptor issues. And then my absolute favorite, and you'll learn to love it too, log rotation issues. Because every single service in your infrastructure does not rotate logs correctly. And it is not enough to just rotate logs. Rotating logs and gzipping means your disk is going to run out slower, but your disk is still going to run out. So rotate and delete. For the love of God, please rotate and delete all of your old logs. There is absolutely no reason application servers need 2-year-old access logs on disk locally. Absolutely no reason. And when you rotate logs, you should also make sure that you rotate based on size and not time. Because when you rotate on time, you will invariably have services that hit errors and decide to write exceptions to disks as fast as the disk can accept those writes, and then the disk will fill up and you'll get paged. So if you rotate on size, it doesn't actually fix the application issue, but it does prevent you from filling up disk by just this infinite loop of just writing exceptions to disk. And that will happen, and that will happen more than once. And you can avoid it by just rotate and delete based on size for some of your logs. And really, the problem with these manual different types of effort is laziness. Operations is filled with laziness. It's probably the only thing better than operations that operations people do is be lazy. And whenever you get these incidents and you have things that you have to react to, short-term laziness might win sometimes, but long-term laziness is fixing the problem so you never get paged again. And if you've got to choose one, choose the latter. Because let's face it, the manual work is never going away, And that's just sort of the nature of the job. You're never going to get out of this sort of manual stuff. But there's some manual stuff like rotating logs or like flushing caches or like dealing with application issues that you don't need to do. You don't need to wake up for at 3 in the morning. So wherever you can, get away from manual work that can be automated. You won't remove it entirely, but you can automate a lot of it away so you aren't waking up in the morning. So speaking of manual work and kind of not being dumb, let's talk a little bit about deployment, which is the biggest source of technical debt that you have right now. And as time goes on, you're only going to accrue more technical debt in deployment because no one seems to care about building and shipping from their machines into production. It's super easy. Git push to Heroku and you're done. Like that's the prevailing culture of the time. And the problem with this is as time goes on, people forget how these things get deployed. If people are deploying things from their laptops, and they are, if you have to go in and deploy it after them, say there's a critical security fix or there's a problem with something, and you've got to go deploy it, there is no feeling worse than not knowing how a service has actually been deployed so you can deploy an update to it. Or even worse, not even knowing how the damn thing was built. And there's going to be a couple services that you now operate where you have no idea how they're built. And at the very minimum, documenting how they're built and deployed is a great way to avoid that tremendous treasure trove of technical debt that you're developing right now. An even better way would be to automate some of that and start implementing continuous delivery, which that Jez guy talks quite a bit about in 2010 and 2011. And by automating your actual delivery process and maybe using a tool like Jenkins or any of the other tools that are going to help you deliver software consistently means you're no longer performing this sort of reverse engineering on your applications to figure out how they were built, how they were deployed, what state did they need when they were deployed, what stars do you have to align before you ship this software. Having that actually defined, ideally in some code that you can check in, means you now have an artifact that you don't have right now where everyone can look and see how that thing was deployed. And setting aside the code archaeology problem, that also helps you scale as a person better. Because as soon as someone else can come in and implement their own delivery process and check that in, that means you are no longer having to decipher READMEs or read wiki pages or emails to try to figure out what are the service requirements for this application. And the sooner you get that into code, the more you're going to save in terms of time. I kind of think of continuous delivery as like compound interest, to borrow the metaphor from technical debt. Like technical debt you're slowly losing and you've got interest being charged on that. But when you automate your delivery pipelines, you have compound interest working in your favor. So if you start with just something small, a small, simple application, and get the build, the test, and the deploy all automated for that, over time, that's going to start to pay dividends that might offset some of the frustrating technical debt that the infrastructure is going to accumulate over time. And really, deployment isn't a difficult thing to do. It's really difficult to just sit down and write what is supposed to happen. And you've got tools at your disposal that are going to make that deployment process easier to manage over time and make it easier for you to avoid accruing technical debt with deployment or performing deploy archaeology with some of these services by putting it into Puppet, by putting it into Jenkins, by putting it even into bash scripts is still far preferable than these black magic deployment processes that you might have running around right now. There's also the manual work. You can avoid a tremendous amount of technical debt by just automating yourself out of this manual work, automating yourself out of incident response. The more that you get incident and monitoring response into code and into Datadog or Nagios or Sensu or something, the easier you're going to have managing these services as they go from 1 year to 2 years to 6 years down the road. And if you think about it, you've now been running Jira for 6 years. You've been running Confluence for 6 years. You've been running web applications for 6 years. You ran Drupal for like 5.5 years. Like, you've got all of these services, and if you don't remove yourself from some of this manual work, you're going to spend weeks and maybe even months trying to figure out what you were supposed to do or manage these services and their upgrades and their outages and things like that. And there's nothing that's too difficult to automate. You have the tools. You just have to want to do it. So I implore you to choose the long-term laziness that allows you to be lazy over time instead of the short-term laziness in making the wrong decisions earlier in that process and letting them fester over time and accrue interest. That sort of overarching philosophy of don't be dumb, I want you to internalize and think about that every single time you SSH into a machine, sudo to root, and then get ready to do something. Like, don't be dumb. And imagine if somebody else in the organization did that, you would have no record of what they did. And so would you trust everybody else in the project to have that sort of same superpower? Probably not. You probably want everybody to have sort of centralized change control, centralized delivery process, and a sort of single point in your infrastructure where you can all sort of collaborate together instead of everybody running off in different directions and changing things with no audit trail whatsoever. So over the next, 6 years, you're going to learn a lot. You're going to screw up a lot, but don't worry, everybody else is going to screw up a lot as well. There's a lot to learn in the process of becoming an ops. Right now, you're just some dumb application developer who doesn't know anything. But in time, that will change. And in the process of learning things, you're going to laugh, and you'll cry some more. And as long as you learn from your mistakes and make sure that you make better mistakes tomorrow than you're making today, that's progress in the right direction. And whether it's manual work, reducing that, implementing continuous delivery pipelines, or making the applications and the project more secure, that's still improvement in the right direction. So I wish you good luck. It's going to be a fun 6 years, and I want you to just go automate everything. There's no reason not to. That's all I've got. So good luck in 2010. Thank you.